All right, we are back at it with Module 3, Lesson 2. This is 5th grade once again, of course. Now, Mr. Kennedy, your host here. Let's take a look. We have our objective is we will make equivalent fractions with sums of fractions with like denominators. So if you notice, all of our units for 1A are ninths. So we have 4 ninths plus 1 ninth. So number 1 asks us to show each expression on a number line and to solve. So first thing first, let's go ahead and solve. We should see here that we have 4 ninths and we add 1 ninth. So 4 ninths plus 1 ninth is 5 ninths. Let's go ahead and show that in the number. So we've been representing 0 at one end of our number line and 1 at the other end of our number line if our sum is less than 1. So now I can say, well, I need to break this one whole into 9 parts. So I need 8 partitions. 1, 2, 3, 4, 5, 6, 7, 8. That gives me 9 parts. Now I can say this is going to be 0 ninths. One whole is equal to 9 ninths. And of course I would say 1, 2, 3, 4. This is 4 ninths plus 1 more is my 5 ninths. Now you can go back and fill in your 1 ninth, 2 ninths, 3 ninths, but I'm going to stop there because I know that my information is accurate and it shows my answer on that number line. So I have 1/4 plus 1/4 plus 1/4 plus 1/4. I know that my number line can be 0 to 1 because when I add 1/4, 2/4, 3/4, 4/4, I know that my total sum is 4/4. All right, so 3 partitions give me 4/4. And I say, well, this is going to be 0/4, 1/4, 2/4, 3/4, and 4/4. And I'm just going to show each one of my jumps. It's plus 1/4, plus another 4, plus my 3rd 4th, and my 4th 4th is equal to 1 whole. So 4/4 is equal to 1 whole. And we showed that on our number line. Moving right along. Same thing with C. We have 2 7s plus 2 more 7s plus 2 more 7s. So we have 6 7s. We know that 6 7s is less than 7 7s, and 7 7s is equal to 1 whole. So therefore 6 7s can fit with inside of 0 to 1. My sum is less than 1. So therefore I can say, well, I need 7 parts. 6 lines will give me 7 parts. 1, 2, 3, 4, 5, 6. This is going to be 0 is always going to be 0, whatever your unit is, and our unit is sevenths. This would be 1 7, 2 7, 3 7, 4 7, 5 7, 6 7, and 7 sevenths. I'm not going to fill them all in. I am going to fill in all of my multiples of 2. So I would jump and say 2 7s. It's my first fraction, or my first add-in. Then I would jump another 2 7s, skip 3 and go to 4 7s. That's my second add-in. Then I would skip 5 and go to 6 7s. And that is my answer. All right. Now D changes it up a little bit. It says 2 times 3/5. So we have 3/5 2 times. So I could write this as 3/5 plus 3/5. That's my first part here, my multiplication part. And then I have to add another 1/5. So now if you notice, we have 3/5 plus another 3/5, which is 6/5, plus another 5th, which is 7/5. All right, and before we show this on our number line, let's think about 7/5. We can take 5/5 away from 7/5, which is equal to 1 whole. And then how many fifths do we have left over? Well, 7/5 minus 5/5, 7 minus 5 is going to be 2/5 remaining. So 7/5 is equal to 5/5 plus 2/5. All right, let's take a look at that on the number line. Now we can't go out to 1 here because 7/5 is greater than 1. 5/5 is equal to 1. 7/5 is greater than 1. So we got two options. We can either just draw our fifths in and go 0/5, 1/5, 2/5, 3/5, 4/5, 5/5. What did we say? 5/5 is equal to 1 whole. 6/5, 7/5. And we know we had 3/5 plus another 3/5 plus 1/5 to get our 7/5. Or 0, we're going to go all the way out to 2 because we know 7/5 is less than 2 but greater than 1. 7/5 falls between 1 and 2. So now we're going to split our number line into 2 wholes. And then we say, well, in between each whole, we need fifths. So we need 4 lines to give us 5 parts. So now we would say, well, we know 1 whole is equal to 5/5. 2 wholes is going to be double that and be 10/5. So let's go ahead and look at it on this number line. So we say 3/5, 1, 2, 3/5, plus another 3/5, 4, 5, 6/5, plus 1/5, 7/5. So there's our number line. There's all the important fractions. Let's get that 0/5 in. If you wanted to, you can put your 1/5, 2/5, 4/5 in, as well as your 8/5 and your 9/5. So there's your two options. Either way, we see that we come to 7/5 for our final answer. Here we didn't do individual jumps. We could have did 3/5, 3/5 plus 1/5, but I chose to do individual. So 1, 2, 3, 4, 5, 6. That's my 3 plus 3/5. All right, let's take a look at the next problem here. So it says express each fraction as a sum of 2 or 3 equal fractional parts. That's important. They have to be equal fractional parts. Then it says rewrite each as a multiplication equation, and then it says show part A on the number line. All right, so let's take a look at this first part. It's 3 parts we have to do for A, and 2 for B, C, and D. So the first thing it asks us to do is to represent this as the sum. So we know it's going to be addition of either 2 fractional parts, or we can do it as 3 fractional parts. So it's either we either have 3 fractions or 2 fractions. If you choose 3 fractions, you're going to say 6 divided by 3. If I had 6 11ths and I divided it into 3 parts, we know our units are 11ths, but how many each person is going to get? It's going to be 2 for the first person, 2 for the second person, and 2 for the third. 2, 4, 6. If we did 3 equal fractional parts, if we decided to do 2 equal fractional parts, it would have been 3 11ths plus 3 11ths equals the 6 11ths. All right, so you could have either one for this. For A, you could have had your 2 11ths 3 times or your 3 11ths 2 times. Either way, let's stick with our original 2 11ths 3 times and show that on the number line. All right. So, and we're not going to forget to rewrite it as a multiplication. So we know that we would have 0 and 1. We know that we only have to go up to 1 because 6 11ths is less than 11 11ths, which is equal to 1. We have 0 11ths on this side of the line. We need 11 parts, so we need 10 partitions. It's going to be 5 here and 5 here. All right, so now we know we have 1 11, 2 11ths. Let's go ahead and jump to those 2 11ths. And it's 3 11ths, 4 11ths, 5 11ths, 6 11ths. I'm not going to label all of my 11ths, just the ones where I'm making the jumps. All right, and we were supposed to write this as a multiplication sentence, multiplication equation, which is a multiplication sentence. So we're going to have 1, 2, 3 groups of 2 11s. All right. Now for B, we don't have to do the number line. We're just going to write it as either 2 or 3 equal fractional parts. We know that 9 is not divisible by 2. So if we listed all of the factors of 9, we would have either 9 times 1 or 3 times 3. They both equal 9. So therefore, we're going to do 3 equal fractional parts of 3. So we're going to have 3/4 plus 3/4 plus 3/4. You can see my 3 equal parts. And this can be rewritten as 3 groups of 3/4. All right? Let's go ahead and look at C and D. Same thing. Now you should notice that 12/8 is greater than a whole. I can take a whole out and say, well, 8/8 is equal to 1. And how many 8s do I have left? 8, 9, 10, 11, 12. I have 4/8 remaining. So we know that this is equal to 1 and 4/8. But right now we're just trying to break it down. We're going to break it down into 6/8 plus 6/8. Or we can have 3 groups of 4. We can have 4/8 plus 4/8 plus 4/8. All right. And for this top one, we will write this as 2 groups of 6/8. And what do you think we're going to have for the bottom blue? Hopefully you said 3 groups of 4/8. All right, same thing here. For 27, it can only be divided by, it can't be divided by 2, so it's going to be divided by 3. And we know that 3 times 9 equals 27. So we're going to have 9/10 plus 9/10 plus 9/10, which is equal to 3 groups of 9/10. All right. And if we wanted to change this improper fraction to a mixed number, we would say, well, we know that we can get 10/10 would equal 1 whole. How many 10s do we have in 27? We can get another 10/10 for 2 wholes. And then we would have 7/10 remaining. So we could change 10/10 as 1 whole and another 10/10 as a whole plus 7/10. So 2 and 7/10. 27/10 is equal to 2 and 7/10. All right. Look at number 3 here. I think this is the last problem we're going to look at. It says express each of the following as a sum of the whole and a fraction. So we have to find out the sum of the whole and the fraction. We just did that for the last parts where we're going to change them to a mixed number, basically. All right, and for parts C and D, we're going to show on the number line. Let's look at A. So we have our mixed number. Remember, we said there's a couple ways we can do this. I just showed you the number bond where we say, well, how many fifths? Our units is fifths. How many fifths can we get out of it? 9/5 to make 1 whole. Well, 5/5 makes a whole. And then we have 4/5 remaining. This would be said 1 and 4/5. We also said we could do our division. The fraction bar says division, so this is 9 divided by 5. Well, 9 divided by 5. We know we can get 1 group of 5 out of 9. And then we say, well, 5 times 1 is 5. 9 minus 5 is 4. Remainder 4. Remainder 4 what? 4/5. All right? You should see how these relate. You have your quotient, you have your remainder, and your divisor. All right? Your whole number, your numerator, and your denominator. All right, let's go ahead and take a look. Most people think this is a little bit easier to do it this way. I know that I'm going to have 2 halves plus 2 halves, that's 4 halves, plus another 2 halves, 6 halves, plus 1 half. Alright, so this is one whole, this is one whole, this is one whole, and I have a half remaining. So 7 halves is equal to 3 and 1 half. Alright, long division. You could have said 7 divided by 2. How many 2's can I pull out of 7? Let's skip count by 2's. 2, 4, 6. 8 is too many. I only have 7. I can't take 8. So it's going to be 1 2 would be 2. 2 2's would be 4. 3 2's would be 6. So it's going to be 3 groups of 2. Give me my 6. How many do I have remaining? 1. And that's my answer. I get that. My quotient is my whole number, my remainder is my numerator, and my divisor is my denominator. Alright, so they ask us to put C and D on the number line. Same thing. How many 7's can I get out here? So 7 7's is 1 whole. 14 7's would be 2 wholes. 21 7's would be 3 wholes. How many do I have left? I used 21, so I'm going to say 25 minus 21. I have 4 remaining. 4 7's remaining. You should see my, it's supposed to be a plus there. You should see my holes here. This is 1 whole. 7 7's another whole. 7 7's another whole. So that's 7 times 1 2 3. So we have 3 groups of 7 7's plus 4 7's. 3 groups of 7 7's is 21 7's, or 3 wholes. Then we have 4 7's remaining. Alright, so now let's go ahead and show that in the number line. We know that this is going to be 3 and 4 7's. So 3 and 4 7's is between 3 and 4. So I know I'm going to have to go all the way out to 4 on my number line. So I'm going to start at 0 and go up to 4. You say, well, why 4? Because 3, 1, 2, 3 holes, and then I have part of a hole. I know that 3 and a little bit more is going to fall between the whole number of 3 and 4. So if I want to split this into 4 parts, I need 3 lines or 3 partitions. Each partition is going to be out to 7's. So I'm not going to split the first 3 partitions because they're going to be the holes. So that's going to be my 1 hole. This is my 2nd hole. And this is my 3rd hole. Now I need this is going to be split into 7's. I need 6 lines. And I'm going to use 4 of those partitions. 1, 2, 3, 4. So this would be 1 hole, 2 holes, 3 holes. This would be 3 and 1 fourth, 3 and 2 fourths, 3 and 3 fourths, 3 and up. I said fourths. It wasn't fourths, wasn't our units. Our units was 7's. So that's going to be 3 holes, and this is going to be 3 holes and 1 7, 3 holes and 2 7's, 3 holes and 3 7's. This is 3 holes and 4 7's right here. That's where we would be. All right, let's take a look at D, which is 21 ninths. So how many ninths can we pull out of 21? How many nines can we pull out of 21? So we're going to use the same method. We're going to say 9 ninths. Skip count by 9's. 9 ninths equals 1 hole. Another 9 ninths, which would be 18 ninths, equals 2 holes. And I know I can't pull another hole out because I would need to have 27 ninths, but I only have 21 ninths. So that means I'm going to have to say 21 ninths minus 18 ninths gives me 3 ninths. So I have 3 ninths remaining. So therefore, 21 ninths is equal to 2 wholes and 3 ninths. Alright, so I know that 21 ninths is going to fall between what two whole numbers? 2 and 3. 2 because this is my whole number here, and I know that it's greater than 2, and I know that it's also less than 3. It's not quite 3. So we're going to fall in between 2 and 3. That means I'm going to have 0 and 3 on my number line. And then I need 2 partitions of the 3 parts. Quite. Call that 1, this will be 2. Now each whole has to be partitioned in the ninth. I'm not going to partition my first 2 wholes because we have 2 wholes and it's a lot of lines to write. So that's going to be 1 whole, which is my 9 ninths, 2 wholes, which is my 18 ninths, and then I'm going to say, well, I need ninths between 2 and 3. So that's going to be 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. And I know I need to add 1, 2, 3 more ninths. So this is going to be the 3 ninths mark. This is going to equal right here. It's going to be my answer of 2 and 3 ninths. You may say, well, Mr. Kennedy, why didn't you put your ninths in here? We could have, but that's extra marks that I don't really need to make because I know that 9 ninths is equal to 1 whole, and another 9 ninths that I will put in here will be equal to another whole, which will be 2. All right, so that is our homework assignment. Go ahead and check your work. Hopefully you tried it on your own and you're checking it. And if you have any questions, bring them to class in the morning. Happy learning. Keep up the good work.